Hello, everyone, and welcome to tonight's webinar, which is ESP and WAVE, Take Control of Your Scleral Fitting. And ESP stands for the Eye Surface Profiler, which is made by Eaglet Eye. And of course, WAVE is a contact lens system with some really remarkable software that we're going to learn a lot more about tonight if you don't already know something about it. So tonight, we're really privileged to have some impressive people here to help us work on this program tonight. We have Daddi Fadel and we have Kathryn LaClair. And I am Ted Newell, by the way. I am a business development manager here in the United States for Eaglet Eye, and I'm going to be the moderator, and I'm going to go through the Eaglet Eye technology slides and try to keep it brief because you really want to hear from Kathryn and Daddi. But Daddi Fadel, for those of you that don't know her, and most of you do know her, first of all, she's a doctor of optometry, a fellow of the Scleral Lens Society, a fellow of the British Contact Lens Association, a fellow of the American Association of Optometry, and a fellow of the International Association of Contact Lens Educators. And you've probably seen her speak at one of a million different meetings. She does a lot of educating, a lot of speaking. She ran a practice in Italy for almost 20 years before taking up a position at the University of Waterloo, at the School of Optometry there, which is a terrific program. Daddi is also famous for what's known as Euroschool, but that really stands for the European School of Specialty Lens Fitting, and they have numerous programs throughout Europe every year. And so this lady must have a lot of miles on her, whatever airline she favors. And I'd like to know what vitamins she takes because I don't know how she does it. We joke about that at Eaglet Eye. And then Kathryn LaClair with WAVE, and she is ABO certified, National Contact Lens Examiner certified, and she's a WAVE lab consultant. And she lives in the great city of Cincinnati, which is where I live, Cincinnati, Ohio. And so she's going to be helping us with WAVE. So we have these two really talented people here tonight to help us understand how the WAVE contact lens system works and how using it, you can take more control over your specialty contact lens designs. So this is sort of humorous. Some of you may know our head of marketing, Elena Barrios, but she was trying to figure out, gee, what does take control of your scleral lens fitting really mean? So she asked ChatGPT, and this is what ChatGPT came up with. It's pretty amazing. It's the 5 points that ChatGPT came up with are perfect. Being knowledgeable, using available data, making effective use of your tools and technologies, tailoring the scleral lens fitting to the individual needs of the patients, and streamlining the fitting process to save time, resources, and so on. So we both got a big kick out of that when we were setting up the slides and talking about this. But AI is a big subject these days for many good reasons, and this was the result of us using some AI in preparing our slides. So today we will learn about scleral fitting, getting quality data, using technology, customizing the lenses, and streamlining the fitting process. And so the agenda, which I've sort of hinted to already, is that we're going to first talk about the eye surface profiler, which we affectionately call the ESP, which is an introduction to the whole concept of corneal scleral profilometry. Then Kathryn's going to take us through the WAVE contact lens system, where you customize scleral lens design, and you can also customize ortho-K design and other specialty lenses. And then we're going to go into the clinical cases with Daddi Fadel, where we're using the ESP and the WAVE software to design really customized lenses, and also talk a little bit about good practices in handling. So that's the agenda of tonight, and I'm going to go ahead and start by moving into the whole concept of scleral lens fitting using the eye surface profiler. And by the way, before I get going, I have to say something. We had over 200 registrants for this program tonight from 47 different countries. So I'm sure some people, we would assume, are waiting for a recording sometime in the near future. But we actually saw some people that were signing in tonight from, I think, maybe the furthest away. The award for the furthest away will be Macedonia. And we saw a few others from other European countries. So welcome to the program. Glad you're staying up late. I hope you have lots of coffee. But here I'll move on to a transformation of scleral lens fitting is happening. And where does this come from? And it is that over the last number of years, a lot of research has been done, publications have been published. There's a big step forward in understanding the sclera and what it means to fitting scleral lens fittings, or scleral lenses in general. And what the results of all this research has been is that the scleral shape is pretty asymmetric, irregular. Only about 6% or maybe a little bit more are what you would say are spherical. So we have a lot of different shapes in the sclera, and it really affects the comfort and the performance of the lens for the patient. And we can't predict scleral shape by just assessing the cornea alone. And you can see these images below where we have them labeled group 1, group 2, group 3, and group 4. Group 1 is very spherical. Group 2 is a regular toric. That's sort of a toric, almost looks like it's with the rule. And then you have group 3, which is quad specific, and group 4, which is highly irregular. And wherever you see dark colors like dark blue, that's very deep, that's below the reference sphere line, and the reds are above, and greens and yellows are almost at the line. But we'll go into that more in just a second. Here you can see the difference between placida topography and profilometry. And it's a big difference. We need more scleral data to really, fit lenses successfully. And this is a good example of why. So the eye surface profiler, the ESP, is a technology that we've designed specifically to efficiently fit specialty lenses. And we got our start primarily in the scleral lens area, but we've moved into ortho-K, RGPs, and so on. So we get a full cornea image, limbus to limbus, and the sclera. We get real data. We're not extrapolating data, and we're not stitching data together. Then with that data, we come up with maps similar to what you've seen in the past slides, which are objective analysis of the scleral. They could be lacerations, scleral imperfections and changes. You get objective analysis of that. And it's the end of we say guesstimation, or it's the end of your conversation with a technician at a lab where you say, the eye is irritated at about 180 degrees, maybe 7 millimeters out, and I think we need to, raise the edge of that lens by 100 microns. And they send you a lens, and the eye's still irritated, and you have that same conversation again, and you say, well, maybe we need to raise it a little bit more. We need to change something else in the eye. No more of these conversations with the labs where you're trying to help them imagine what your problem is. Even if you're sending in images, even if you're sending in OCT images or slit lane images, it's still a lot of guesswork. So the eye surface profiler, we call it a corneal scleral topographer. You can get images of the cornea and the sclera up to 20 millimeters in diameter. There's, like I said before, no extrapolation or stitching. About 500,000 data points are taken, and we're accurate to 2 microns at the cornea and 10 microns at the sclera. And we are providing you with 14 maps, 2 calculators, and over 18 ocular parameters to help you analyze the eye and to help the lab. And the magic is that the labs have the same data, and we'll talk about that more in a minute. So we're trying to help. We talked a minute ago about streamlining the process. Well, we're trying to help make that happen. You take the scan, You analyze the 3D data and the 2D data and all the various parameters that you're provided. You fit the lens with what we call, here it's FLFA, but that stands for First Lens Fit Algorithms that we've worked on with all the labs that we work with. And once you've used that First Lens Fit algorithm, then you can connect to the lab with a preformed prescription form that's already filled out. And when you click that submit, all the data goes to the lab. Now, it's a little different with WAVE, which is really interesting and which we're going to discuss some tonight. In that WAVE, because it's a specialized software to really help you really focus on special design for the scleral lenses or for the ortho-K lenses or whatever, that software resides on your computer, but the ESP sends the data to the WAVE software so that you can start working on it, and you'll see that happen later. So we have one camera, 2 light projectors, which are cobalt blue lights. They pick up on the fluorescein coated eye with a Fourier transformation, and from that they gather all that data, that 500,000 data points of data, and we're measuring height. This is what it looks like. We've centered the eye, lower lid down, upper lid up, center on the Purkinje dots. We get the eye focused, take the image, and there you go. That's how fast it is once you have the patient aligned and you're ready to go. And we do have a couple extra pieces of software that we've introduced since this video. You see these 2 little snowballs where my cursor is over here to the right. Those are the focusing snowballs. We now have a vertical line with 2 circles to help you put those snowballs together. And we also have up here, we have what are called quality control indicators for centration, focus, and coverage. And it's either green, orange, or red. And it helps you and or your technician better evaluate how good an image you've taken. So that's really how simple it is to take the image. And then you end up going to the default map, which opens up, and it's a bisphere elevation map. But you can also look at the scleral profile maps, and you can look at eye metrics. We've got a lot of information that I'm not going to bring the actual software up right now. You'll see more of that later. But we provide a ton of information for you to use to help analyze the eye. And anywhere you put your cursor on this bisphere elevation map, you get this data that you see down here. The elevation, the axis, the degrees, and the millimeters in out. So then, after, like I said before, we've done the scan. We use a First Lens Fit algorithm. We connect with a lab, or in the case of WAVE, we transfer the data to their software, and you can work away on designing a lens. We work with a lot of different labs, but tonight the focus is going to be on WAVE. And so, as I said before, we complete the eye exam, look at the data, and we send it over to the WAVE software. And with that, I'm going to stop sharing my screen and hand it over to Kathryn.
Good evening, everyone. My name is Kathryn. I am a clinical lab consultant with WAVE. And thank you again to Eaglet and to Ted for having us this evening. We're excited to be here, and I'm excited for Daddi's presentation too. So before we get to the really good stuff, I did just want to kind of give a brief overview of WAVE, and just if anyone is unfamiliar. And so WAVE is an advanced lens design software that enables practitioners to create a one-of-a-kind custom corneal GP, ortho-K, or scleral lens for your patients, all based on their unique topography maps. So we are completely topography based. There's no fitting sets involved. The designs are all driven from your patient's topography. And how WAVE works, we are compatible with a number of diagnostic devices, of course, the Eaglet ESP. So once you have your baseline scan for your patient, the software is again connected to the device and it's imported directly into WAVE design software. From there, you can make any modifications based on your fitting philosophy to that initial lens. And then once you're satisfied, the order is submitted from your PC and it goes to our internet ordering system, or the IOSS. From there, our contracted lab will download the order and begin manufacturing. Once everything's manufactured, it's sent directly to you, the practitioner, and then it's dispensed to the patient. And then I did just want to show an initial design coming in from the ESP. So again, it's directly linked and it goes directly to the software. At this point, we'll have measured our patient's subjective refraction, or if they're an existing lens wearer, we have their trial lens in over refraction. And with the patient refractive data, we have a couple of options. We can enter in the spectacle plane refraction error, or again, if we have a lens that we've tried on with a known base curve and power, we can enter that information in along with any over refraction. And then with the ESP, the corneal diameter and the pupil size is automatically imported. Once we hit next, we choose a scleral lens. And then the corneal diameter, again, is auto-filled, but you can also set your diameter. We typically recommend 4 millimeters over the corneal diameter, but it's completely customizable. The central clearance is assumed before the lens settles, so we set it to 400. And then WAVE will design your initial lens. So with ESP, we get so many great data points, as Ted mentioned. We're really just letting our software drive from this point. So we can review the lens 360 from the simulated fluorescein, and we can view each semi-meridian. And then again, from here, once we are happy with the lens, we can verify the lens material, color, and then at that point, you're ready to place your order. And with WAVE, our scleral lenses are generally made in freeform, so that allows us to make some very custom modifications based on what your patient needs. For instance, if we see a lens that looks like this, we know we need to modify our alignment angle because our edges are just a little steep here, 360. So with WAVE, we have an easy set of modification tools where you can adjust the alignment angle. You can also adjust your limbal clearance and central clearance. For the limbal clearance and alignment angle, those changes, they can be applied to the lens 360. You can also apply to half of the lens or to only a specific quadrant or semi-meridian, and you're choosing the amount in microns to increase or decrease. When modifying your central clearance, that can also be increased or reduced by your desired micron amount as well. And then just as an example, if we go back to the lens that we saw that was too steep, we would just import our lens into the software and we would go to our modification area. In this case, we would be decreasing our alignment angle by 60 microns. And we'll apply the change to the lens 360. And again, once you're satisfied, you can review the changes. And then again, we would just send that to the lab. And along with the software, we do also offer a robust amount of resources when you're getting started with WAVE and just getting familiar with the software. We do have WAVE Academy, and that houses our certification courses, and we also have our past webinars available. And we do offer clinical support either by a live remote session or by email. And then we have live technical support as well. And along with the resources, we again have WAVE IOSS, which is wonderful. You can use it to track all of your patient orders, shipments, and very easily reorder lenses. And then you can also see what patients are going to be due to be refit. And we also do offer quick guides for all of our lens types. They're just kind of an FAQ. So when you're getting started, it's a great reference for a lot of common modifications. And lastly, we do also have a concierge service that is an alternative to designing lenses. So this is available where you can send topography and patient prescription to our designers, and we will be able to send you a custom lens in about a week. Modifications work very similarly. We take your exam findings and modify the lens and then send it directly to you to dispense. And I think that is it for me. Thank you so much, everyone, for your attention. I am going to go ahead and turn it over to the wonderful Daddi Fadel.
Thank you. Thank you for having me tonight talking about WAVE. And thank you for introducing the ESP and WAVE for the basic how to take the topography of the eye, and also how to design basic designs with WAVE, because this presentation will show a little bit more advanced applications, advanced modification of the lens. And those presentation before the starting this one were very important. So thank you for doing this. So who knows me know that I design all my rigid contact lenses, ortho-K, corneal lenses, and scleral lenses. I used to have the OCT images and design over the OCT. Then WAVE came and transformed my life. So it's very easy, very fast, and the lenses are highly customized. So why it's important to have technology? Customized lens alignment is very important for the lens comfort and to avoid many complications of the eye. It's important to customize anterior surface as well, adding toric, multifocal lenses, decenter the back optics of the zone, the back and anterior, and we'll see how to do this and why we need to do this, in which cases. It will save time in lens design. It will save lenses reordered from the labs, and it will also save chair time. It will reduce the number of lenses applied on the eye, which is crucial, especially during the diagnostic visit. You will see how to manage complex cases. So you can manage complex cases with so many scleral lenses, but you may need to have several reorders to get to the final lens. You can include fenestrations, microvolts, and more technology in the landing zone. And what you need to know is that generally scleral lenses customize the landing zone. Some of the scleral lenses started to customize the limbal area because we noticed that the asymmetry or toricity that we have in the sclera start in the limbal area. And if we don't customize this area, the landing zone is not enough for lens alignment and to avoid limbal touch or limbal congestion as well. And some of them started also to customize the corneal area. WAVE will customize all the lens areas. Only the optic zone will stay spherical. So you will have quadrant specific already in the mid periphery of the cornea, and it will continue in the limbal area and landing zone. I use technology also not to design the lenses, but also to discuss with the patients for their educations and to show them why they need some customization. And I show them the design that they need, and they feel themselves very, very special. And you know that specialty patients, specialty contact lens patients are very special, and because they have ocular surface conditions that may compromise their psychology. So they need time to spend with them. Instead of spending time to apply lenses, remove lenses, apply another lens, and to verify the lens on the eye, you can spend time talking to them, discussing with them, and showing them how you will be designing their lenses. So with WAVE, you will not be applying any contact lens because it's an empirical fitting. You will need to apply any rigid contact lens, should be scleral or corneal lens, just to have the over refraction. We saw before that we need to include the the base curve of the lens, the power of the lens, and over refraction, and WAVE will calculate the lens power for you. So why we need technology? Because we saw in the slide before that the majority of the scleras are asymmetric. Only less than 6% are spherical, and also we saw that there are several studies that show that keratoconic patients have asymmetric sclerals, and the more is advanced the keratoconus, the more is decentered the keratoconus, the more we will have quadrant specific in these cases. So as scleral lenses are majorly indicated in keratoconic patients, we indeed need some customization for the lenses. Why we need technology? Because patients ask for technology. Here are some emails and chat that I received from patients from around the world. They are not asking me if I fit scleral lenses. They are asking me if I fit customized lenses and what technology I use. And sometimes they ask for the technology they want because they are very informed. So a good topography will give you a good design. This is a corneoscleral topography plus WAVE. It will give you highly customized lenses. What will give you the ESP? It will give you information about the cornea, and putting the cord length, you will have information on the sclera as well. You will have information between the two opposite quadrant, nasal and temporal, and also how much toricity you have in the sclera, and information if there is any pinguecula. And this is very important if you want to order some customization, the landing zone, to avoid interaction with the pinguecula. You have to give the lab accurate information to design and customize the lens periphery for this pinguecula. We saw that the ESP also provide an algorithm recognizing 4 different profilometries. So we have spheric, toric, quadrant specific, and irregular. And we saw the study that I showed before from Greg Denier et al. In 2017. They showed that about 40% of sclerals will be irregular, will be quadrant specific, sorry. So you need some customization in these cases. So what you can do with WAVE in challenging cases. So you can manage high toric sclera, you can decenter the back and the front optic zone of the lens. You will have quadrant specific design in all the zones of the lens. You may have oval lenses, microvolt in the lens periphery, and you can also include the microvolt in the corneal area. We saw that it's very easy to use. First thing, you have to have a good topography. I insist on the topography. It's very important to have a good one because the lens design will be based on the topography. The better you have it, the better it will be the lens design. Then you have to include the trial lens for the over refraction. Decide the lens diameter and the word that you would like, and WAVE will design a lens for you. You can accept this design, and for beginners, I would suggest them to just start accepting the design and see the lenses on the eye, and then get to more customized and more advanced application. So this is the first advanced application. It's a high scleral toricity. So I do workshops in different parts of the world, and this was the first one that we did in Ireland, Seo School Island. It was in February 2022, and during these workshops, I have the possibility also to see real patients. So this is a patient of Kian Gildea. He had problems in fitting this patient. You see here his corneal topography is not so special, but he failed to fit him with any scleral lens. Why? Because he had high toricity, scleral toricity. His right eye had a toricity of 1,230 microns, and the left eye 1,180. So just because he couldn't fit these patients with any scleral lens, taking opportunity of the workshop, because during the workshop we have all the technology available in the market. So we had this patient, we mapped this patient, scanned his eye, and we had these maps, and we saw the huge toricity of the scleras. So I took this file with me in Italy, and I designed the lens for him. So this is the design you can see here. So you can see that the toricity was huge, and it's indeed a toricity. With a rule toricity in both eyes. And here you can see that it's not only toric. This is the lens design with WAVE. And you can see the difference between the two opposite quadrants. And here between inferior temporal and superior nasal, it's about 1,100 microns. So it's not only toric, it's quadrant specific. And if you are considering the highest and the lowest point of the lens, you have 1,600 microns of toricity in this lens. This is the right eye. The first lens ordered was the final lens. I was surprised because this was a very challenging case. I was expecting some modification, but this was the first lens ordered, and we didn't have to do any other changes to this lens. This is the right lens. And here you can see that the highest and the lowest was the nasal and inferior. And here you can see the fitting of the lens in nasal and inferior, how was very aligned and very centered. So the problems with the other lenses was that Kian couldn't apply any lens because they were all decentering in the lower part of the eye, and air bubbles are coming inside because of the huge toricity of the sclera, and the lenses didn't have such toricity to avoid air bubbles coming in. So the lens also was decentered. Over refraction with these lenses was also a problem because of the huge air bubble getting inside the lens. So to have the over refraction, Kian used a corneal lens to have the over refraction. He sent me the information of the corneal lens, and we calculated the lens power with the parameters of the corneal lens. This is the left eye. Here again, we had less toricity, we saw it, but again, here between the two opposite quadrants, we have huge difference in elevation. And if we are again considering the lowest and the highest is about 1,000. And here again, between the nasal and inferior temporal, it's 1,000 micron. And here you can see nasal and inferior, how the lens is well aligned, and you can see also very well centered. You can see here is the images of the lens alignment with the OCT. So outcomes, there was no need to reorder the lenses for right or left lenses because the lens alignment was very nice. The lenses were decentered. There was no over refraction, so no remakes for the power of the lens, and the patients was very happy. So I was talking with Elena Barrios about this case, and she told me that they had a previous case before WAVE. They had a similar case in Europe for a toricity about 1,000, and they had to order about 8 or 9, I can't remember, lenses to get to the final lens. With 1,200 microns of toricity, one lens was ordered, and it was the final one. So we are talking about keratoconus, feature in advanced keratoconus. For those who fit scleral lenses, in keratoconic patients, when the cone is descented inferiorly, the lens will be more likely touching over the cone, and in the opposite quadrant, you will have the superior quadrant, you will have excessive clearance. So what to do in these cases to avoid the touch in this part of the cornea over the cone? We need to increase the sagittal height of the corneal area, but by increasing sagittal height of the cornea, of the corneal area here in this area, just to avoid the lens touching the cornea, you will be increasing the sagittal height also in the opposite quadrant, and it's already huge in the opposite quadrant. So you will have about 1,000 micron in one quadrant and about 100 microns in the opposite quadrant. just to avoid that touch over the cone. So this is a normal lens with optic and corneal periphery. What you can do is, in these cases, is decenter the optic of the lens, the back optic zone. So we are talking about the back optic zone. By decentering the back optic zone of the lens toward the cone, you will be vaulting adequately over the cone, but also you will be reducing the clearance in the opposite quadrant. So you are managing both areas of the corneal area. But remember that if you are decentering the optic of the lens, so here we had a center optic and the lens, the optic zone diameter was large enough for the pupil area. By decentering the optic of the lens, the optic zone diameter will fall into the pupil area, and this will create a visual problem. So remember to increase the back optic zone diameter to avoid any visual problem. And you will be still reducing the clearance in the superior area and increasing the clearance in the inferior area. And this is the lens that you will be having. So even if the cone is decentered, you will have adequate clearance where it was excessive and adequate clearance where the lens was touching. How to do that with WAVE? So here you have to go to the fluorescein map, edit optic zone, and then move the optic zone, not the move treatment zone. This is for the ortho K lenses. So you have to move the optic zone and toward the arrows where the cone is, and this exactly what you will be having. This is a lens designed to decentering the back optic zone of the lens, and exactly this, the lens will be on the eye. So another way to resolve this problem, how to do it, is to increase the lens diameter, the optic zone diameter, but only from one part, like this. So you see, in the opposite part, I'm not changing the optic zone diameter. I'm increasing only the optic zone diameter where the cone is to avoid any touch. And how to do that with WAVE? You can do it. Just you have to put one quadrant here and do the change is only one quadrant. So here you can see I increase the clearance amount in that area where the cone is, and you can also play with the clearance. So I increase the first here, you can see that I increase the optic zone diameter, but I can also increase the clearance to have more clearance. And if you want also more area to vault over the cone, is very decentered toward the limbus, you can also increase the diameter of the intermediate curve. So without changing anything in the opposite quadrant. And here you will have a switch and overcome the lens touching over the cone. What you can do, so we resolve this issue by increasing the optic zone diameter only from one part. We cannot reduce this back optic zone diameter from this part because it's over the pupil. Otherwise, we will have problems with vision. So in this case, why we need to reduce this optic zone? So to shift this optic zone diameter here to reduce the clearance, but we cannot do this because it's already on the pupil area. What you can do is play with the vault here with the clearance. So just reduce the clearance from the opposite quadrant. You will have adequate clearance in both quadrants of a decentered cone. So another way to resolve, so we have three options. This is the third option. You can use this option also if you are using scleral lenses that have quadrant specific in the limbal area. So what you can do where the cone is, just increase the vault in the limbal area. So also the peripheral corneal area will also increase. And what you need to do is to decrease the limbal area in the opposite quadrant, and you will also decrease the peripheral corneal clearance as well. So these are different management strategies to manage scleral lenses in advanced keratoconus when they are decentered and the lens is touching the cone and is overvaulting the opposite part of the cornea. What you can do with the WAVE is multifocal sclerals. Is very easy. This is a patient from Italy. So he was wearing soft contact lenses, but he wasn't happy with the lens because the vision was unstable, fluctuating. He has healthy eyes and regular corneas. So I tried with Scleral lenses after his unsatisfaction with soft contact lenses. So in few steps here, you can see the lens on the eye, very well aligned. Again, first lens ordered was the final lens, very low clearance here as well. And the lens didn't settle more. So the lens had some clearance over time. For distance, vision was very nice, and also the vision for near activities was also very good. So the patients was happy, and the vision was stable. Even so, with soft contact lenses, why multifocal lens, soft multifocal lenses do not provide a stable vision? Because the lens is a little bit decentered, and the multifocality of the lens is decentered, so the vision will not be perfect. Also, with blinking, the lenses, the soft lens will move. Scleral lenses will not move with blinking. It's very stable and will not rotate. So to have a very good visual performance, we need a very well-aligned lens, and it should not rotate neither. So what to do in lens decentration, because we know also scleral lenses, not only soft contact lenses, tend to decenter inferiorly temporally. Also scleral lenses can decenter inferiorly temporally. What to do in these cases? With scleral lenses, you can decenter the front optic zone, and the front optic zone is important to decenter not only for multifocal optics, but also to manage high order aberrations, and when you are adding some anterior surface eccentricity. So how to decenter the front optic zone? Before we saw how to decenter the back optic zone of the lens, and here we are decentering the front optic zone of the lens. Before doing any change, you have to add a NAD for this patient, otherwise you will not be able to decenter the front optic zone. So we will add an NAD here, and you go to the curvature front, edit add, and you decenter the lens. So we know the lens is decentering inferiorly temporally. We have to decenter it in the opposite area. So we have to decenter the front optic zone superiorly and nasally to compensate the decentration of the lens on the eye. Oval lenses. So I'm not here to talk why we need oval lenses. I've been talking about oval lenses, the need of oval lenses since 2017. So you can see other presentation of mine why we need these lenses. So the lenses should be, in my opinion, scleral lenses should be based on the VVID and HVID to have a stable lens and to have a uniform clearance from limbus to limbus horizontally, but also vertically, superiorly and inferiorly. How to do this? The easier thing that we can do with WAVE, just have, again, 1/4 of the lens to change, and you need to change the diameter of the lens horizontally. So the horizontal diameter of the cornea and the limbus will be based on HVID, the horizontal visible iris diameter, while the vertical one still making the change is 1/4. So you will be doing this inferiorly and superiorly as well. And here again, for the horizontal diameters, you need to do them, the change in 2 times, nasally and temporally. So you will have larger horizontal vertical diameter and smaller diameter of the corneal area in the vertical meridian, just because VVID generally is smaller than the HVID. In with the rule toricity, when you will have against the rule toricity and the toricity of that cornea is high against the rule toricity, it will be the opposite. You will have the VVID larger than the HVID. So you need to measure both of the iris diameter and set your design based on that two diameter, and you will have oval lenses in the internal part of the eye. So corneal and limbal area will be oval. But remember that the ovality is not 180 and 90 degrees. It can also be oblique. So how to do in these cases? You have just to change the line where you need the changes. So where the ovality is reproducing. In this case, we had this meridian larger than the 45, larger than the 135. So here we have larger VID in 35 and smaller in the opposite meridian. Microvolts, how to do microvolts? So microvolts, you know, they are important to avoid compression and interaction with pinguiculas. So here you can create a vault over the pinguicula where it's presenting. You have an overview of the lens here, but here you can also see the edge. So you magnify the visuality of the screen, and you will see the microvolt in the edge. But microvolts are not only needed in the landing zone. You may have some irregularity in the corneal area, and instead of increasing the clearance all over the corneal area, just to avoid excessive clearance in the opposite part, you can maintain the optimal clearance where the lens is vaulting, and when the lens is touching, you may have a localized vault in the corneal area. And here again, instead of doing the microvolt in the landing zone, you can reproduce it in the corneal area, just in the meridian where this micro elevation is appearing on the cornea. So we are talking about how to take control of your lens parameters. So we saw several clinical tips in keratoconus, and we will see in general cases how to take control also of the the back optic zone radius, the base curve, and also how to change the back optic zone diameter, how the lens design will change in the corneal area. So let's see this. This is a case where we have low clearance in the peripheral cornea. We need to increase that clearance. How to do? You just need to flatten the back optic zone radius, and you will be increasing without changing the clearance, the central clearance. By flattening the base curve, you will have larger clearance in the peripheral area of the cornea. So in case you have excessive clearance in the peripheral cornea, what to do? You have to do the opposite. So you need to steepen the base curve, and you will be reducing the clearance in the peripheral cornea without changing the clearance. So here you see that the clearance, central clearance is always the same. What you are changing only the peripheral clearance in the cornea. So, and if you need more, you steepen more the base curve. In keratoconic patients, so a normal base curve in may be okay for normal cornea because the cornea is prolate, but when it's protruded, central clearance will be optimal, but in the peripheral cornea will be excessive. What to do in these cases? You have to steepen even more the base curve. What you can do, so here you can see by steepening more the base curve, you are reducing the peripheral corneal clearance. What you can do also is to reduce the back optic zone diameter as well, and you will be reducing even more the clearance over the peripheral cornea. And here again, you decrease it more and you will be reducing more the peripheral clearance. So just you can reduce as much as you can the back optic zone diameter, but remember to have it at least as pupil diameter. Otherwise, a little bit more than the pupil diameter. Otherwise, you will have visual problems. So here we saw how to change the base curve, and in this case also reducing the back optic zone diameter, how we are changing the peripheral corneal clearance. Now you will see how we can do changes only in the back optic zone diameter, and everything will be changing in the mid periphery. I'm increasing the back optic zone diameter, and I'm increasing without changing the base curve here. I'm only changing the back optic zone diameter. I'm increasing it. By increasing it, I'm increasing the peripheral clearance in the cornea. In oblate design, so we know that oblate design are generally indicated for oblate cornea, so after refractive surgery or after keratoplasty. But I suggest you to consider oblate design for keratoconic patient. Why? Because oblate design will reduce the lens power. So here you have example of a base curve of 6.5 millimeter having a power of -12. By flattening the base curve, you are reducing drastically the lens power. Why we need to reduce lens power? To reduce lens thickness, so the lens will decenter less, the comfort will be increased, but especially vision will be ameliorated. We know that keratoconic patients have problems with high order aberrations, and we know that managing high order aberration are still a challenge. But what you can do in ameliorating the vision, not the visual acuity, but the visual quality, is reducing the lens minus power. With oblate design, you can do that. So this is a prolate with 6.5 millimeter. I'm doing an oblate design, but you can see here, we saw that by flattening the base curve, I'm increasing the peripheral clearance in the cornea. I don't want this. So in these cases, with oblate design, remember to decrease the back optic zone diameter. By decreasing this, you will also decrease the peripheral clearance as well. So you will have great vision, and you will have great clearance in the corneal area, and the lens will not decenter. Because if you have excessive clearance, even as with prolate lenses, this is excessive in the peripheral cornea. And when you will have excessive clearance peripherally, the lens will more likely decenter. So by decreasing it, the lens will be more stable on the eye. So in the conclusion, having a good fit will it will allow you to have a well-aligned lens, but a well-aligned lens over time will maintain corneal health. So when fitting scleral lenses, vision is not a priority. The comfort is not a priority. The priority is corneal health. If the cornea is happy, if the conjunctiva is happy, the fitting is good. Then you can check the vision, and you can check with the patient if they are happy. But before the patient is happy, his ocular surface should be happy. This technology will allow you to have a happy eye, a happy patient, and you will also be happy even in complicated cases. And you saw in this presentation there are some tips to use for managing some of the complicated cases that we have. And we need creativity, because scleral lenses are not only science, they are art, the art of scleral lenses and the science of scleral lenses. And in art, you need some creativity, because some cases are not possible. It's not possible to resolve some cases with simple designs. You need some creativity. You need to think outside the box to resolve that patient's problems. Technology will also allow you to have a better communication with the patient, and they will feel more special, and also will allow you to have better discussion with your peers. As you saw in the first case with Kian Gildea, we managed that case together, but that was the only case that we managed together. From that case, Kian now is designing his own lenses for same problems in complicated cases, and he is having success. So by managing the case with technology between peers, you are not only helping the patient, but you are also helping your colleague and teaching your colleague during the fitting process, and they will be able to design lenses and make more patients happy. So you are not customizing the lenses. I'm against in saying that with technology you will customize the lens. Yes, you will be providing the lens very highly customized, but what you are customizing in the care of your patient, which is very different than the lenses. You are not the seller of the lenses. You are treating the patient in their whole. So taking control of your scleral fitting will allow you definitely to have customized care. Thank you.
Daddi, thank you very much. It was a lot of information. It was just really, really terrific. So thank you very much. I also want to thank Kathryn for sharing her information with us about the WAVE software. And then, of course, that was reinforced, of course, by Daddi. But I know that both of you put work into this presentation, and we benefited from it. All the viewers benefited from it. So again, thank you very much for being up this evening and helping us out. And, this was really quite good. If there's any more questions, put them in the chat. We've got a couple more minutes here where we could take questions. Yeah, okay. So, Daddi, do you have time to re-explain using oblate design for keratoconus patients instead of prolate?
Yes, so oblate design is when you have a flat base curve and the periphery of the corneal area is steeper. So you have a flat base curve. By flattening the base curve, you are reducing the minus power of the lens. With prolate design, the lens is flatter in periphery and getting more steep as it comes to the central area of the lens, so to the base curve. With oblate design, you will have a flat base curve, a steeper peripheral area in the cornea, and then you will have flatter zones. By flattening the base curve, the important thing here is not to align with the flat cornea after refractive surgery or after keratoplasty, but to reduce the lens power. I will show you here. These are calculations that I use for my lens design. So let's see that you have a base curve of 6 millimeter and the lens power is about 10. If you are having a 7 millimeter, so you are flattening, flatten the base curve from 6 to 7.5. This is the lens power that you are having, plus 1.2 diopters. From minus 10, you will have plus 1.2. Is it clear? So from steep lens, you are flattening the lens and reducing the minus power.
Okay, so we have another question. Would you have time to show how to decenter the OC? Thank you.
Which OZ, anterior or posterior? So I will show you both of them. So here we have, so this is how to decenter the back optic zone. You have to go to the fluorescein map, then decenter where the cone is, inferiorly and temporally, and then you have to put apply, and this is the lens profile in the back optic zone. So where the cone is, the lens will be vaulting, and the opposite quadrant you are reducing the clearance. This is the back OZ. For the anterior OZ for multifocal lenses, so you have to go to the front optic, so curvative front, edit add, and as the lens is decentered inferiorly and temporally, you need to decenter the optic zone in the opposite areas, so superiorly and nasally, to compensate the decentration of the lens. Okay, so the lens is decentered like this, so the optic zone of the lens is decentered inferiorly and temporally. You just decenter nasally and superiorly, and you will have the optic zone of the lens centered with the pupil, and the performance of the multifocal optics are definitely better.
One more question, coming back to the oblate design. How do you decide which keratoconus eye will require oblate?
So I don't decide. Ultimately, when I start to have more than minus 2.5, so not only in keratoconic patients, high myopes, minus 2.5 is not high myopes, but when I start to have more than minus 2.5 of lens power, I start to have oblate to reduce this minus power and get it from minus 2.5 to plano. So you can, when you will have, when you can start thinking of oblate when the lens power is more than minus 3 diopters. So you by oblate design, you will be reducing this lens power and ameliorating vision, even if only minus 3 diopters.
And then earlier we had a question, what is the first fit success rate with lenses ordered through the ESP?
It depends on the topography. It depends on the topography, the quality of the topography. If the quality of the topography is good and you have some experience with WAVE, I think one lens order, well, the more that you get experience with WAVE and how to take good topographies, I think maximum 2 lenses, probably 4 lens power as well.
Of course, it's going to depend on the challenge that you're faced with, right? And so some cases are simpler than others. Okay, so I think that is I think that's the end of the questions. All right, so we're going to wrap this up again. Sometime in the very near future, a week or so, we'll have this on video that we can share. So if you want to go through some of these things again, you can. And once more, I'm going to thank Daddi for the time that she shared with us this evening and all the knowledge. Thank you very much from Canada, which is going to get colder. And thank you, Kathryn, for your time this evening. Really appreciate it. Good night, everybody.